Hello and welcome to Algebra 1 Lesson 47. In this video, we're going to learn about complex fractions. So I know not all of you took my course on pre-algebra, but hopefully before you got into the Algebra 1 course you're currently in, you've at least seen complex fractions at some point. Now, what is a complex fraction? Let's just start out with that. Well, it's a fraction that has a fraction in its numerator, its denominator, or both the numerator and the denominator. So for example here, we have 5/6 plus 1/8 over 7/2. So there is a fraction, there's actually two fractions being added together in this case, in the numerator of the complex fraction. This is the numerator. And there's also a fraction in the denominator. You have 7/2 there. And then you can kind of think about this as your main division or your main fraction bar. So your main division. And why do I say main division? Remember, if you have fractions, you are dividing the numerator by the denominator. Something like 9 over 3 is the same as 9 divided by 3, which is 3. Right? It's the numerator divided by the denominator. It is no different here with a complex fraction. We have this numerator here, although it's a complex numerator, 5/6 plus 1/8, is divided by this denominator here, 7/2. So how do we go about simplifying one of these? Well, I gave you two methods in my pre-algebra course to do so. The first one, and one that we probably use most often, is to simplify the numerator and denominator separately. Then you would just perform the main division. So for example, if I wanted to start out, if I had 5/6 plus 1/8, let's just deal with this part first. I would get a common denominator going, and for this one, 6 factors into 3 times 2, 8 factors into 2 times 2 times 2. So the LCD would be 2 times 2 times 2 times 3, right? Which is what? It's 8 times 3 or 24. So I would take 5/6 and I would multiply by 4 over 4. And then I would take 1/8 and I would multiply by 3 over 3. Let me scroll down. I'm going to take this off the screen for a minute, but we'll come back to it. So 5 times 4 is 20. Plus 1 times 3 is 3. And this is over that common denominator of 24. So 20 plus 3 is 23. And then over 24. So if I simplify the numerator of the complex fraction, I would get 23 over 24. So let's just erase all this and go back up to the top. So I'm going to put equals out here. I know I wrote a bunch of stuff, but essentially what I'm doing is I'm saying the numerator of the complex fraction is 23 over 24. Then the denominator of the complex fraction is 7/2. So we think about it as 23 over 24 divided by 7/2. And if it makes you feel more comfortable, you can write it like this. You can say, okay, well, this is 23 over 24 divided by 7/2. We all know how to divide with fractions. We take the first fraction, or the leftmost fraction. In this case, you'd think about that as the top fraction. And we multiply by the reciprocal of the fraction on the right, or the second fraction. So this would be 23 over 24 times, flip this guy, 2 over 7. In this case, you take, again, 23 over 24 times, take the reciprocal of the fraction on the bottom, 2/7. Either kind of way you want to do it. This is what we've been working with so far. This is kind of the new way that we're going to see kind of moving forward in math. So, I want you to get comfortable doing it in this way. I know you're already comfortable doing it in this way. If the first few times you do this, you've got to convert it from this to this so that it makes sense for you in your mind, then go ahead and do it. But after, 10 or 15 problems or so, you want to try to merge into doing it this way because, again, as you move forward, this is going to be more common. Okay, so let me just erase this. We know how that sets up. And what I want to do, I want to cancel any common factors before I multiply. So now I can cross cancel a 2 between here and here, and this would be 12. So now what I'm going to be left with is a 23 times 1 for my simplified numerator over 12 times 7, which is 84. So I get 23 over 84 as the simplified complex fraction. Now, I taught you another method to do this in the lesson. Let me erase all this, and let me just kind of erase this real fast. The other method is to multiply the numerator and the denominator of the complex fraction by the LCD of all denominators involved. So in order to do this, I'm looking for the LCD. I want to look at all the denominators. So I have a 6 here, an 8 here, and a 2 here. That's all the denominators that are involved in the complex fraction. I'm not looking at just the denominator of the complex fraction. I'm looking at individually each denominator that's involved. So kind of in the numerator, if I was to block this out, let me get a black color and just kind of black this out. I have two denominators. I have a 6 and an 8. So I'm thinking about 6 and I'm thinking about 8. And then kind of if I look at my denominator of the complex fraction, let me black this out for a minute. I have a denominator of 2. So that's where I'm getting those numbers from. I don't want you to be confused. Now, once I have those numbers, I just find the least common denominator that I can form. Or again, that's the LCM, the least common multiple of these numbers. So what is the LCM of 6, 8, and 2? Well, I know that 2 doesn't factor. I know 8 is nothing more than 2 times 2 times 2. And I know 6 is what? It's 2 times 3. So it looks like we're going to have an LCD of 2 times 2 times 2, or 8 times 3. So that's going to be 24. Now, if I take 24, and again, I multiply it by the numerator and denominator of the complex fraction. So I'm going to multiply this part right here by 24. And then this part right here by 24. What's going to happen? I'm going to distribute this to each inside of the parentheses. And what am I going to get? 24 times 5, 6. Let's do that over here. This is going to cancel with this and give me a 4. 4 times 5 is 20. So let me write 20 over here. And then plus, I have 1/8 times 24. And this is going to cancel with this and give me a 3. 3 times 1 is 3, so I'd have plus 3. So then plus 3. And then over. Down here, what I have is 24 times 7 halves. So 7 halves times 24. And we can see this would cancel with this and give me a 12. 12 times 7 is 84. So this equals 20 plus 3 is 23 over 84. So I get the same answer either way. It's just a different method. And as far as which one you want to use, just depends on you, right? If you have trouble finding the LCD or understanding what I'm doing here, you might want to do it the first way to kind of break it down for yourself and then kind of move into this method as you get more comfortable. If you're completely comfortable with what I just did, then the LCD method is usually faster. Okay, so why are we talking about complex fractions again? Well, the reason that we're talking about complex fractions again is because it comes up when you get to rational expressions. Somewhere in your chapter on rational expressions, usually right after you learn how to add and subtract, you're going to talk about complex fractions with regard to rational expressions. So it's the same thing. You have the same type of problem. It's just more complicated because there's variables involved. But you use the same methods to simplify. So for example, if I have 9x squared minus 4 over 2x to the 5th power over 3x cubed minus 2x squared over 2x to the 5th power, let's solve this guy just using kind of the first method. And what I want to do here is just simplify everything completely before I kind of set up the division. So in the numerator here, I have 9x squared minus 4. The trick here is just to try to factor everything before you get started to see what can factor. And the trick with rational expressions is always to factor as you're working, right? You want to end up seeing what you can cancel. 9x squared minus 4, I know that's the difference of two squares. That is 3x plus 2 times 3x minus 2. Then this is over 2x to the 5th power. Now, I'm dividing by, or my main division is here. This is the numerator of the complex fraction. This is the denominator. So I would be multiplying by the reciprocal of this. So then the denominator here, in this denominator of the complex fraction, I know that gets confusing, but this is your denominator for the denominator of the complex fraction, or this guy. That is going to come up here, 2x to the 5th power. Then the numerator is going to come down here. But I see that I can factor out an x squared. So let me just go ahead and do that real quick. So x squared times, if I pulled that out, 3x cubed divided by x squared would be 3x. And then minus 2x squared divided by x squared would be 2. Now, before I do this multiplication, what can I cancel? I can cancel this factor of 3x minus 2 with this factor of 3x minus 2. Remember, this is multiplication here. Multiplication. So these are factors. Now I can also cancel this 2x to the 5th power with this 2x to the 5th power. And what am I going to be left with? Well, I'm just going to have a 3x plus 2 in the numerator over x squared in the denominator. So not too bad overall, and this is kind of an easier example. And not that they get harder, they just get much, much more tedious, right? That's the trick. It just gets much, much more tedious, and so you need to take your time and go step by step so you don't make any silly mistakes. And just one more thing before I kind of get to the next problem. Again, when you see your main division, if you're uncomfortable setting it up like this, go ahead and take this guy and say, okay, I have 3x plus 2 times 3x minus 2 over, 2x to the 5th power. Take your main division and put a division symbol out there. Keep this as it is. So I would factor out the x squared and then have 3x minus 2 and then over 2x to the 5th power. When I set it up like this, it reminds me to multiply this guy right here by the reciprocal of this guy. I set it up in one step here, but again, it might take you two because you might be so used to kind of doing that from pre-algebra, and that's fine. Again, 10 or 15 problems go by, you want to kind of just convert to the new method because, again, as we move forward in math, we're going to see it more and more as this versus what we saw back in pre-algebra. All right, let's take a look at another one. So I have 3x minus 3 over 9, and then this is over x over 3 minus 5 over x minus 1. So again, what I'm going to do is use that kind of first method where I simplify the numerator and denominator completely, then I kind of perform the main division. So the first thing I would do is I would just find the main division bar. So this is the numerator of the complex fraction. This is the denominator. That's your main division. Okay. So for the numerator, is there anything I can do to simplify that? Well, 3x minus 3, I could factor out a 3, and I'd have x minus 1 inside the parentheses. This is over 9. 3 and 9 share a common factor of 3. So this can be canceled with this. This would be a 3, and this would be a 1. Now this is over. For this one, I have to do a little bit more work. I have x over 3 minus 5 over x minus 1. Now let me kind of scroll down a little bit. And let me do this down here. So x over 3 minus 5 over x minus 1. What would the LCD be? Well, it would just be 3 times the quantity x minus 1. So I would multiply this by 3 over 3. And I would multiply this by x minus 1 over x minus 1. And what would that give me? X times x is x squared. Minus x times 1 is x. And then minus 3 times 5 is 15. Then this is over that LCD of 3 times the quantity x minus 1. And I'm not going to multiply it. I'm just going to leave it in factored form for right now, just in case it'll cancel with something later on. You don't want to go through a multiply and then have to go back and factor it. You just, you want to save yourself a little bit of work. Can I factor x squared minus x minus 15 into the product of two binomials? Well, this would be x and this would be x. Can you give me two integers whose product is negative 15 and whose sum is negative 1? Well, 15 only factors into 1 times 15 or 5 times 3. So no, that's not going to be possible. So this is going to be prime. And so I'm going to drag this back up to the top. And now I'm going to go ahead and set up my multiplication. So I have the numerator here, or the top part, as x minus 1, that quantity, over 3. And then I have my denominator down here, which I'm going to flip it, right? I'm going to take the top part, multiply it by the reciprocal of the bottom part. So we would have 3 times the quantity x minus 1 on the top over x squared minus x minus 15 on the bottom. So is there anything I can cancel before I do the multiplication? This 3 with this 3, and then that's it. So what I'm left with is x minus 1, that quantity, times x minus 1 again. We could say that's x minus 1 squared if we want. Or your teacher might want you to go through and actually do the FOIL, just to get some practice. That's fine. And then this is over x squared minus x minus 15. And just for the sake of completeness, let's go ahead and do that. If I have x minus 1, that quantity squared, we can use our special products formula. We know that would be x squared minus 2 times x times 1. So basically 2x. And then plus this guy squared, which would be 1. So x squared minus 2x plus 1 over x squared minus x minus 15. Again, a lot of people will rather leave it in factored form so that you can show your teacher, hey, there wasn't anything that I could cancel. But again, that kind of goes back and forth as far as what he or she may want you to do. All right, let's take a look at another one. So I have b squared over 4 minus a squared over 20. And this is over 1 over b plus 1 over 5. So again, I have my main division here, right here. So this is your numerator. This is your denominator, right, for the complex fraction. So if I look at this, I have b squared over 4 minus a squared over 20. That's my numerator. So I'm going to start out by just simplifying that guy. Now the LCD here would be 20, right? 20 is going to factor into what? 2 times 2 times 5. 4 factors into 2 times 2. So essentially you need to multiply this by 5 over 5, and then you'd have a common denominator. So this would be 5b squared minus a squared, I don't need to do anything over here, over that common denominator of 20. And then this is over. If I look at this guy right here, 1 over b plus 1 over 5, the LCD is going to be 5b. 5 I'm not going to be able to factor, and I can't do anything with b either. So I just have to multiply the two together. So 5 times b. So I'd multiply this guy, 1 over b, times 5 over 5. And I'd multiply 1 over 5 times b over b. So 1 times 5 is 5, plus 1 times b is b. So you get 5 plus b, or you could put b plus 5, doesn't matter, over 5b. Let me kind of reverse that and put b plus 5. All right, so let's erase this real quick. And again, we're going to set up our multiplication. So this top guy, 5b squared minus a squared over 20, is multiplied by the reciprocal of this guy. I'm taking this and I'm dividing by this. So the first one, or the top one now, stays unchanged. We multiply by the reciprocal of the bottom one. So this is 5b over b plus 5. Now, can I do anything to factor this guy right here? If I didn't have that 5 there, I could do b plus a times b minus a, be the difference of two squares. But I do have the 5 there, so that stops me from being able to do that. So there's not really anything I can pull out there. Now, over here, I know I can do some canceling because 5 and 20 have a common factor of 5. So this can cancel with this, and I'll put a 4 here and a 1 here. And then I'm basically done. Right? All I want to do now is just multiply. I can, leave this in factor form and say, okay, this is b times the quantity 5b squared minus a squared. Or you can go through and use your distributive property. Again, that's going to be your personal preference or your teacher's preference. Again, this is over. 4 times the quantity b plus 5. And again, if we want to go through, we can use our distributive property just to show both answers. B times 5b squared is 5b cubed. Then minus b times a squared is a squared b. This is over. 4 times b is 4b. And then plus 4 times 5 is 20. So we get 5b cubed minus a squared b over 4b plus 20. All right, let's take a look at one final problem kind of using this method. And then we'll kind of look at the LCD method to wrap up the lesson. So if I look at 6 over x squared plus 2x over y squared, then this is over 4 over x minus x over 2. So again, this is the numerator for the complex fraction. This is the denominator for the complex fraction. This part right here is your main division. Okay, your main division. So for the numerator, if I have something like 6 over x squared plus 2x over y squared, the LCD would just be x squared times y squared. Nothing else we can do there. So I'd multiply this by y squared over y squared. I'd multiply this by x squared over x squared. And the numerator would end up being 6y squared plus 2x cubed over x squared y squared. Okay, now for the denominator down here, what do we have? 4 over x minus x over 2. So the LCD here would be 2x. So 4 over x times 2 over 2 minus x over 2 times x over x. So this would be equal to 8 over 2x minus x squared over 2x. So I'll write this over 8 minus x squared, again, over 2x. So let me erase all this real quick. So we're going to set this up as a multiplication. So this top part right here, 6y squared plus 2x cubed over x squared y squared, will be multiplied by the reciprocal of this guy, which is 2x over 8 minus x squared. Now, what can I do to simplify? I noticed that I could pull out a 2 from here, but it's not going to do me any good. But I'm just going to go ahead and factor it anyway. Let me kind of scroll down a little bit. So if I pulled out a 2 from here, I'd have 3y squared plus x cubed. This is over, again, x squared y squared times 2x over 8 minus x squared. Nothing I can cancel between numerator and denominator here. Nothing I can cancel between the numerator and denominator here. The only thing I can cancel is one factor of x here with here. Right? This would be x to the first power. That's it. Other than that, I'm pretty much done. Now, I multiply 2 times 2, I would get 4. So I can put this as 4 times that quantity, 3y squared plus x cubed. And then over, then I would have xy squared times the quantity 8 minus x squared. Now, your teacher may let you leave it in this format. In most cases, that's what I would do. But she might also want you to get a little practice and use your distributive property. So 4 times 3y squared is 12y squared. Then 4 times x cubed is plus 4x cubed. And then over, you have xy squared times 8. That's 8xy squared. And then you have xy squared times negative x squared. That is minus x cubed y squared. And for some of you, you'll want to write this where 4x cubed is in the front here. So you can do that. You can switch the order and say, okay, this is 4x cubed plus 12y squared over, switch the order here, negative x cubed y squared plus 8xy squared. All right, let's take a look at a few that deal with the LCD method now. I think for the majority of you, you will prefer to use this method because it's a lot quicker to use in most scenarios. Now, with that being said, it's a little bit challenging to kind of understand what you need to actually do when you first start utilizing this method. But just like anything else, if you practice this enough, you'll get really good at it. And again, you'll prefer this method because generally it's a lot quicker. All right, so let's take a look at a plus 3 over 4, and then over 4 over a plus 3, and then minus a plus 3 over 36. So recall that the complex fraction has a numerator, and let me kind of label this real quick. This is the numerator. And then it also has a denominator. So this is your denominator. And then recall that this is your main fraction bar right here. So let me just highlight that. This is the main fraction bar or main division. Again, as I've said before, when you have a fraction, it's the numerator divided by the denominator. So we have our numerator divided by our denominator. So in the method that we've been using up to this point, I would take this numerator, and once it's simplified, in this case it already is, I would multiply it by the reciprocal of this simplified denominator, right? I'm just basically performing a division. In the case of the method we're going to use right now, we're going to kind of speed up the process a little bit, and we're basically going to clear all these denominators. The way we're going to do that is we're going to multiply the numerator of the complex fraction and the denominator of the complex fraction by the LCD for all the fractions that are involved in the complex fraction. So if I were to look at each denominator individually, for all the fractions I have involved, I have this denominator that's 4, a denominator that is a plus 3, and a denominator that's 36. So to get the LCD, I just think about the LCM, the least common multiple, of these three values. Again, I'm thinking about 4, I'm thinking about 36, and I'm thinking about the quantity a plus 3. Well, this one's pretty easy because if I think about 4, it's what? It's going to factor into 2 times 2. 36 has 4 as a factor, right? 36 I could factor into 4 times 9, right? 4 again is 2 times 2, and 9 is 3 times 3. So for the number part of this guy, I would basically have 2 times 2 times 3 times 3, or just 36, right? If 4 is a factor of 36, then 36 is going to be the number part. Then times, I have that a plus 3, that quantity. So this over here, this a plus 3. So once we've found the LCD, which is usually the most challenging part of this for students because they're not fully up to speed on that yet, we want to multiply the numerator and denominator of the complex fraction by that LCD. And again, your denominators for each fraction are going to disappear. So let me erase this real quick. We know what the numerator and denominator is at this point. And I'm going to put a multiplication symbol right here. And I'm going to be multiplying the numerator of the complex fraction by this 36 times the quantity a plus 3. And I'm going to do the same thing to the denominator. And why is this legal before we move forward? Again, this quantity over this quantity is equal to 1, right? Any non-zero value over itself is 1. So 36 times the quantity a plus 3 over 36 times the quantity a plus 3 is 1. It's a complicated form of 1, but we are still multiplying by 1, and so we're not changing the value. All right, so to kick this off, 36 times the quantity a plus 3 multiplied by a plus 3 over 4, we can see that 36 would cancel with 4 and give us a 9. So essentially I have 9 times the quantity a plus 3 times the quantity a plus 3 again, which I can just simply write as 9 times the quantity a plus 3, and this guy is squared, right? Or if you want to write it out, you could do a plus 3, that quantity, times a plus 3. Does not matter. Okay, then over. Now this is going to distribute to each term. So it's going to start out right there. And what's going to happen is in that particular case, this a plus 3 is going to cancel with this a plus 3. And then 36 times 4 is going to give me 144. Then I have minus. So I have this minus sign. Now, I'm going to use my distributive property for this term. And let me erase this part right here. In this case, the 36s are going to cancel. And I'll have a plus 3 times a plus 3. So those two quantities. Again, I can write a plus 3, that quantity squared. Or I can write it out, a plus 3 times a plus 3. Okay, so now what we want to do is just simplify. So we've gotten to that stage now. And again, I want to talk about a common mistake. I've talked about this in almost every video since I've kind of introduced this, but I want you to understand. This is multiplication here in the numerator. I'm multiplying 9 times the quantity a plus 3 times the quantity a plus 3. So I'm multiplying those 3 factors together. I don't have straight multiplication in the denominator, right? I have a subtraction sign here. I have 144 that is subtracting away the product of a plus 3 times a plus 3. So these are factors. But this 144 is not a factor of anything, right? It's subtracting away the result of this multiplication. Again, if I don't have straight multiplication in both the numerator and the denominator, I can't go through and just cancel stuff, right? I see students all the time. They'll say, okay, well, I can cancel this with this, and this with this, and then, okay, well, 144 divided by 9 is 16, so this with this, and put a 16. You cannot do that. If you had, and let me just change this scenario up a little bit, give you a different example, something like 144 times the quantity a plus 3 times the quantity a plus 3, now these are all factors. It's just straight multiplication here. So in this case, I can go through and cancel this with this, and this with this, and this with this, and get 16. I'm going to end up with 1/16 there. But that's not the situation we are presented with. And so again, we've got to act according to what we receive. So this is a minus sign here. 144 is subtracting away the result of the multiplication here. So please understand that you can't go through and just cancel there. Okay, so now that we've kind of settled that, what could we do to simplify here? Well, in the numerator, I'm just going to keep that in factored form. In the denominator, I want to go through and use my special products formula to get the result for this. I'm going to subtract 144 minus that result, and then I'm going to try to factor that guy and see if I can then cancel with something in the numerator. And I know This gets really, really tedious, but it's just something we have to do. All right, so I'm just going to copy the numerator. 9 times the quantity a plus 3 times the quantity a plus 3, and then over. So the formula for this, a times a is a squared. Then the middle term, I know that I'd have 2 times a times 3, so that's plus 6a. And then the final would be 3 squared or 9. Now, here's the kicker. I am subtracting away the result of this, okay? So that means I'm subtracting each and every term away, or I'm subtracting the whole thing away. So one good way is to put this inside of parentheses, and then when you drop the parentheses, you're going to change the sign of each term. So I'd have negative a squared minus 6a minus 9, and don't forget that you have the 144 out in front. And then what I'm going to do here is I'm going to subtract 144 minus 9. That's going to give me positive 135. So I'm going to write this as 9 times the quantity a plus 3 times the quantity a plus 3 again. And then over, we have negative a squared, then minus 6a. And again, 144 minus 9 is plus 135. Now, the question would be, can I factor this and then cancel one of those factors with something up here? Well, I'm going to tell you that you can factor it, but nothing's going to cancel. We're going to go through and factor it anyway. So the first thing I'm going to do to make this easy for you, I'm going to factor out a negative 1. So the way that I do that is I just put a negative 1 out in front of parentheses, and I change the sign of each term inside. So this was negative, now it's positive. This was negative, now it's going to be positive. And this was positive, now it's going to be negative. So now it's very easy for me to factor this because I have a leading coefficient on a squared that's positive 1, and that's what we're used to. And so give me two integers whose sum is positive 6 and whose product is negative 135. So if I think about 135, pretty easy. It's what? 27 times 5. 27 is 9 times 3. 9 is 3 times 3. And so if I think about possible factors, the one that jumps out right away is what? 15 and 9, right? 15 and 9. So if I did positive 15 and negative 9, so plus 15 and negative 9, the sum is going to be positive 6. The product's going to be negative 135. So let's just erase this and this. We'll just kind of drag this up here. And what you're going to see is that nothing is actually going to cancel here. I don't have any common factors. A plus 3, that quantity, a plus 3, that quantity, and 9 are my factors in the numerator. Negative 1, a plus 15, and a minus 9 are my factors in the denominator. There's nothing I can cancel. So for most teachers, you would just report your answer in this format. For others, they want you to go through and kind of multiply everything together. So we can do that real quick. So 9 is going to be multiplied by the result of this. So we know that this is a squared plus 6a plus 9. Then if I do the multiplication, let me kind of just do this down here, that would be 9a squared plus 54a plus 81. Okay, so that's going to be my numerator. Then this is over. Down here, we just factored this, so we know what it is. It's negative 1 times, again, this would be a squared plus 6a, and then minus 135. And then a few things you can do. You can write the denominator as a squared plus 6a minus 135, and just put this negative out in front. You'll see that in a lot of answers. Or you can just make each term the opposite of what it was. So you could say, okay, this is negative a squared, and then minus 6a, and then plus 135. There's quite a few different ways you could write this. It's just a matter of what your teacher wants from you. All right, let's take a look at another one. We have 36 over x squared minus x squared over 6, and then this is over 6. Now don't get confused with this one. This is your numerator for the complex fraction. This is your denominator. Okay, the denominator does not have to have a fraction involved. It can just be a number 6. But in order to not confuse yourself here, go ahead and write it as 6 over 1. So now it's clear when I'm thinking about 6 over 1, the denominator is a 1. And then for 36 over x squared, the denominator is x squared. And then for this guy, x squared over 6, the denominator is a 6. So what would the LCD be? Well, just be 6x squared. So then I can erase all this and just say, okay, I'm going to multiply this by 6x squared over 6x squared. So if I do this, 6x squared times 36 over x squared, the x squareds would cancel. This would cancel with this, and I'd have 6 times 36, which is 216. Then minus, let me kind of erase this real quick. You'd have 6x squared times x squared over 6. The 6's would cancel. You'd have x to the 4th power. So x to the 4th power, and this is over. If I have 6 times 6x squared, that's just 36x squared. So, is there anything that I can do to factor this guy? Well, if 216 was a perfect square, I could use the difference of two squares there, but it's not. So there's not really anything I can do. A lot of you will like to flip your answer around and say, okay, well, this is negative x to the 4th power plus 216 over 36x squared. That's fine. Either way is acceptable. All right, let's take a look at one final problem. I think that all of us can agree that this is a much faster method. You just have to be able to understand it. And again, it doesn't take long to understand. You just have to be able to identify what denominators you're looking at to produce your LCD. So for this one, we have y plus 1 over x minus 2 minus x plus 2 over x minus 2. And then this is over y plus 1 over y plus 2 minus x plus 2 over y plus 2. So what I'm looking at here is an LCD. That's what? The denominators here are the same, x minus 2 in each case. The denominators here are the same, y plus 2 in each case. So all I can do is just multiply the denominators together. I can't do any better than that. But again, notice how in the numerator of the complex fraction, I'm looking at this denominator, this denominator. In the denominator of the complex fraction, I'm looking at this denominator and this denominator. So again, you're looking at all the denominators involved of that complex fraction. So this one, this one, this one, and this one. All right. So once we have our LCD going, all we need to do is multiply the numerator and denominator of the complex fraction by that LCD. So x minus 2, that quantity, times y plus 2. Now this is pretty simple to do because in this case, when I multiply here, in each case, the x minus 2 is going to cancel, and I'm just going to be left with the y plus 2 times the numerator. In other words, this is going to cancel with that in each case. So y plus 2 times y plus 1. Let's write that out. And I'm going to leave it in factored form for now. And then I'm subtracting away. And you can put that inside of brackets, or just remember that you're subtracting the whole thing away. You have y plus 2 times x plus 2, right? Those two quantities. All right, then this is over. For the next one, in a similar way, the y plus 2 is going to cancel here and here, right, when I do the multiplication to each. So I'm going to be left with x minus 2 times y plus 1. And then minus. In this case, I'll have x plus 2 and then times x minus 2. Okay, so now once we get in this format, a lot of you will stop and say, well, there's nothing I can cancel. That would be wrong. And then a lot of you will incorrectly say, well, I can cancel, between the numerator and denominator. I can go this with this. Again, you can't do that because we have subtraction involved here. If it's straight multiplication, if all you have in your numerator and denominator is multiplication, cancel away. But if we have subtraction or addition involved, and I know that you're seeing the subtraction here and the addition here and here, and you're saying, well, how is that different? It is different because these are factors, right? This whole thing is multiplied by this whole thing. This subtraction sign is separating these two. There's no multiplication involved in that, right? This is a factor and this is a factor. So that's how you got to look at it. And again, this is one of the most common mistakes that I see. And so that's why I talk about it in each and every video, so that at some point you would stop and say, okay, I can't cancel this with this. No, big no-no. Okay, one of the things I want you to look at is that in the numerator here, I have a common binomial factor of y plus 2. In the denominator, I have a common binomial factor of x minus 2. So what happens if we pull that out? If I pulled it out, so in this case I'd have a y plus 2 out in front, So inside of, let's say, brackets, I would have what's left, which is y plus 1, that quantity, minus the quantity x plus 2. Now this is multiplication. This is a factor, and this is a factor. This whole thing here, let me just highlight it. The whole thing is a factor. Now, this is going to be over if I pull out the x minus 2 here. Inside of brackets, I'm going to have y plus 1, that quantity, minus, over here I'd have x plus 2. Now, we can cancel between the numerator and denominator here because we are canceling common factors. Again, let me kind of show this. This is a factor, and this is a factor, okay? So we don't have any subtraction here. If I had this minus this, and this plus this, or this minus this, I can't cancel, right? Because there's addition and subtraction involved. I don't have that. What I have is multiplication. I have two factors here that are being multiplied. I have two factors here that are being multiplied. So I'm going to cancel this entire factor that consists of the quantity y plus 1 minus the quantity x plus 2 with this factor, again, of the quantity y plus 1 minus the quantity x plus 2. This over this is equal to 1. They can be canceled. So what I'm going to be left with here, once I cancel that out, is just going to be a y plus 2 over an x minus 2. And again, I know that when you first start doing this, particularly in Algebra 1, it's kind of the first time you're introduced to these concepts, it can be very confusing what you can cancel and what you can't. Again, if you're only looking at multiplication, so in other words here, this quantity y plus 2 is multiplied by this quantity, which inside has the quantity y plus 1 minus the quantity x plus 2. This is multiplication. You just have factors here. Okay, same thing down here. You just have factors here. Now, within those factors, you do have addition and subtraction. I know that's what makes it confusing, but again, this thing right here is a factor which can be canceled with the same factor down here. So that leaves me with what's left, which is y plus 2 over x minus 2.